Hey guys, my name is Frank, and this is the Pothumb Programming video log. Today, I'm starting a series on how to program a tile-based platforming game called Rabbit Trap. I'll be designing the game as I go, but it will eventually feature tile-based collision detection and response, scrolling maps, loading levels, sprite animation, and interactive game objects. In this first part of the series, I'll be talking about how to build a strong foundation for the game. The concepts I'm going to explain are strongly rooted in object-oriented programming and can be used in any program to improve organization and modularity. This might seem boring, but if you use this approach, it can save you hours of editing and frustration and leave you more time to focus on fun stuff like level design and graphics. So be sure to watch this video. In this video, I'm going to talk about the model view controller approach to organizing a program and how the different components of this example work together in the main.js file. Then I'm going to talk about how this structure increases maintainability and modularity. As always, feel free to use the comment section and be sure to check out the links to the source code and working example in the video description. And if you learned something, give this video a like. So basically what I have here is just an example of a model view controller architecture where you separate out your game logic from your display logic, and you also separate out your controller logic. So I have my game logic stored in the game class, the display logic in the display class, and the controller logic in the controller class. And each one of these handles its own business, and it's totally separate from the other. So I'm not going to run into any issues with having references to the game logic inside of the display. And I'm not going to have the controller logic reference inside of the game. I'm going to have all these different components interact with each other through their public methods inside of the main.js file context. And by the way, each one of these classes is defined in its own individual file. You don't need to have your own individual files, but it makes it a lot easier to just use these different things in other applications if I choose to. For example, the engine, I might want to use this fixed time step engine inside of another application at some point, so it's nice to just store it in its own file. But anyway, what all this code does for this example is basically the game class controls a color value. Right here, that's the color variable from the game class. Basically, it just increments the different red, green, and blue channels inside of a color value to change these different colors that you're seeing on the screen. And then it will talk to the display class, which governs things like the canvas and resizing the canvas when the screen resizes and rendering. And the game will hand a color value to the display, and the display will render it on every frame. And the engine takes care of frames. As for the controller, I didn't really have anything cool to do with the controller for this example, so all it does is take user input from the keyboard and tell the user which key he or she pressed. So for example, I just pressed the A key, that's key 65. So basically what I'm trying to say is I want to keep things as organized as possible for this Rabbit Trap game, and I want you guys to kind of think about organization of code before you start developing a game, because if you just jump into things and try to mesh all this together in one big file with references going between different components, it's going to get very messy very fast. And here's an example of that I want to show you. So I define all my components, I define my engine, it's going to run at 30 frames per second, and I'm handing in the render and update function. Down at the bottom of my main.js file, I'm going to start my engine, and that's going to execute the render and update function 30 times per second until I stop my game engine. So the render and update functions I define up here, and these are them right here. So the update function is just going to tell the game to change that color value, and that's what the update function of the game does. Just increments this color value in a random direction gradually to change the color. Now the render function is also going to be called on every frame of my game loop. And inside, I'm actually going to be communicating the game's color value to the display. And I'm going to have the display object draw that color value to the on-screen canvas. So here's a great example of why this is so good. So I could just as easily write object literals to govern my display logic and my game logic. And you've seen that if you've watched my other tutorials. I'm kind of sloppy. I just throw stuff together with object literals. Here, I'm not doing that. If I had written object literals, I could put a reference to game.color directly inside of the display's render color function. Or better yet, I probably wouldn't have even had a render color function. I would just have a render method that handled rendering the entire thing. The reason I have two here is because render color draws a color to a buffer canvas, and then display.render renders that buffer canvas to the final on-screen canvas that you see. So the old version of how I wrote my code, or just the sloppy way that I write my code, would just be to put two object literals on the main JS file, and one would be display, one would be game, and I would have a reference to game.color inside of my render function, and display would just draw that color directly to the canvas. Now, the reason this is bad is because say I want to change the name of my color variable to hue. If I go ahead and I have a reference to game.color inside of my display, and I change the variable color to hue inside of my game object, now all of a sudden I'm editing my game class or my game object to change that value to hue, and I have to go into my display object and change all the references to game.color to game.hue. Now that's a pain. I don't want to have to do that, and it's unnecessary, so I don't see why I do it anyway. With this method, the MVC approach, you don't actually have to have any internal references to any other components. The display only has references to itself inside of itself. The game only has references to things that it controls. So how do they communicate? They communicate just like this. They communicate through public methods. So display can only communicate with other objects like game and controller through public methods that it has. So if I come into the display object here and I take a look at render color, you can see that it just takes a color value, and inside of it, it does exactly what I said. It just changes the buffer's fill style to the specified color and draws that color to the buffer canvas. And then here's the render function, and all this is going to do is draw the buffer canvas to the final display canvas. I'm not going to get too much into detail on that, but you get what's going on here. Now, I could have just as easily gone like this inside of this function and said game.color had I made these object literals instead of classes. But that's actually really bad practice because, like I said, if I change something inside a game, it might break my display object and prevent it from working. So that's twice the editing that I'm going to have to do, because I'm going to have to change all the values in display as well as all the values in game. So this is just a much cleaner way of doing things. So basically, this is how you want your different components to interact. And just take a look at this main.js file. It's really short. Everything is super clean. I just have my two functions here, render and update, that I hand into my game engine. And here I'm defining everything. This is super clean. I don't have huge object literals to take care of, just sprawling out across my screen here in my editor. And to instantiate everything, it's real simple. I just add my event listeners for the screen resize and the keyboard inputs. And I just resize my screen initially so my canvas fits the screen when I start up, and I start my engine and everything runs the way I expect it to. So using the MVC approach, or just separating out the different components of your game into logical groups, is a really great way to keep your code maintainable and modular. And I'm going to get into why in the next part of this video. So now I want to talk about how this approach makes things more modular and more easy to maintain. So obviously, right off the bat, it's a lot more organized. You can see that clearly. I have my different components referenced here and instantiated here in one single line each, rather than having big sprawling object literals defined. And by separating these things out into their own classes, I have the option of putting them into their own files, which makes things even more organized, because I could have all of these different classes right on top of each other in one big file. Or I could separate them like I did into their own files, and now if I want to edit the game logic, I only have to deal with 42 lines of code apparently, instead of having to search through one big file. So that's obviously one way that this technique lends itself to easy maintainability. Then there's the other thing I mentioned, where you don't have internal references to one component inside of another component. And like I said then, it's a lot easier to just work with public methods and have your components communicate via public methods, kind of like is happening right here in the render function. Display is interacting with game through a public method called renderColor rather than having an internal reference to game.color, which would be a lot harder to maintain because if I change game.color in the game object, I'm going to have to go through display and edit all of those references to game.color. So this is another way it lends itself to maintainability. Now, what about modularity? Okay, well, I've got a engine class down here, which is basically a fixed time step engine. Now, I can use this engine in any application that I want to, and it's very easy for me to do that because this is a totally self-contained class that I store in its own file. Now, I don't have to store it in its own file, but by storing it in its own file, I can very easily just reference that single file in another application, and then all of a sudden, bam, I have a perfectly good game engine for a whole nother game, and I didn't even have to write code for it. I already had it on hand. But if I were to have that game engine integrated into all my other components, it would be a lot harder for me to extract the engine components from, say, the game logic, and that just isn't very modular. The way I have it set up now is very, very modular, and it will save me a lot of time in the future when I need a game engine object. So sometimes I write my code this way. For most of my tutorials, I just throw stuff together in one file because I want everything to be there for you guys to see up front. I don't want to have to bring things in from other applications, but this is how I would go about writing a more structured application, and that's what I'm trying to do. I'm trying to write this game Rabbit Trap, and I just want it to be very structured, and I want everything to go smoothly. So using the MVC approach and separating my game logic from my display logic and my controller logic is just going to make everything go super smooth throughout this whole process. So anyway, I hope this has been a good explanation of how everything is going to be for this Rabbit Trap thing, and I hope you guys are interested in what's going to come because I expect it to be a really cool game. Before I wrap things up, I want to talk about my HTML for this example. So I actually am going to do a whole bunch of parts in this series, and rather than having to upload the sprite sheet for this example 1,000 times to my GitHub page or however many parts I have, I don't want to upload this multiple times to my GitHub page because I don't want to waste memory space. So I'm just going to use the same graphics. I'm going to use the same HTML file and CSS file, and I'm just going to write new JavaScript files as need be. So that's going to keep the memory footprint on my GitHub page a little bit smaller for this whole series that I'm doing. So anyway, the way I'm going about that is inside of my HTML, I'm dynamically determining which JavaScript files to load based on a URL variable specifying the part number. So when I come into my actual HTML page here, and I look at my URL to the rabbittrap.html file, at the end of it, there is a question mark and a 1, which is the part number for this example. Now, if I wanted to get to part 2, I would just come in and type 2. I haven't actually made part 2 yet, but that's how you would access part 2. So I'm accessing these different parts with a URL variable that is just the part. And I have a default to where if you don't specify anything, it just brings you to part 1. So that's what I'm doing. And this big chunk of code in the middle of my HTML file is taking care of that for me. So it defines all the sources I'm going to use, and that's just these files here. It gets the URL variable or that part number from my URL, that 01 after the question mark. And then it goes ahead, it checks to see if it's a viable part. If there is no part specified, it just sets it to part 1. And then it just loops through and adds a script tag for every single JavaScript file in the application. So I'm always going to have controller, display, engine, game, main, and manifesto is just my script for the video. And I'm just going to add a new script for each one of those, and I'm going to parse together the URL or the source attribute to match whichever part I'm in. So hopefully that was a good explanation of how I'm actually getting these things in. And if you had any questions about why my HTML was weird like this, that's the reason. I'm just trying to save memory space on my GitHub page. So I'm being cheap, but I kind of figured out this cool little script to just import JavaScript files based on what part I'm in. So anyway, that is an explanation of that. And to wrap things up, I just hope you guys learned something from this. I hope you stay tuned for the other parts of this series because those are going to be a lot cooler. They're going to go into stuff like graphics and physics and just more game designy stuff. This was just about how to organize your code so you can actually get started and be successful and not run into any snags down the road. So I hope you guys learned something. I hope you enjoyed the video, and I'll see you guys next time.